Yeah, comes on everyone. Let's start off. Yeah, last thing that we did was polar coordinates in 3D. So we'll be starting off with officially a chapter, vectors. So vectors will be the, again, kind of, end of the day, it is still based on math, but we'll be doing it what is related to the physics part. So quite an important one, because literally everywhere as we go ahead in mechanics and whatever chapter we're doing, we keep encountering, these vectors and these components and all that stuff. So in that sense, it is a foundation chapter. So let's see, what is this? Again, like I keep saying, no need to write the notes. Just focus on listening to the class, do the problems. You'll get the PDF anyway end of the session. So just try to absorb as much as you can. So first thing. So before directly jumping into what is a vector, we need to define something. A physical quantity. So what's a physical quantity?
Anything that can be measured.
Yeah. So any quantity that can be observed in an experiment and that can be measured, or that can be measured observed in an experiment. We have a bit of a theory there. So listen, right? So example, speed, mass, force, temperature, etc. So on. I can give you a lot of examples. Now, there are other types of quantities also, which can be observed in an experiment you can't measure. For example, let's say, are you scared of a snake? Generally, I'm scared. If you're not scared, you're a strong person, right? Others, you need to keep your cams on. If your cams are not on, you'll be removed from the group, right? Second thing, so if you're scared of a snake, are you scared of a scorpion? So the question is, can you tell me by how many times are you scared of the snake compared to a scorpion? If let's say you're scared of the snake by X, can I say the scorpion is X by 2 times scary?
It is abstract concept.
So basically, you can't put a number for that, right? Let's say your brother comes and beats you and you're angry on him, right? And next time, let's say there's a fight between you and you're angry on him. So you can't define by how many times or by what factor you're more angry, on him compared to the last time. So there are other physical quantities. These are called non-physical quantities. So we don't study them in science. Or maybe if you're a humanities person, like psychology and all that stuff, maybe you study there, but we don't do that in science. So that is one classification we need to know. Non-physical quantities are like fear, hunger. We don't deal with this kind of stuffs, which we cannot measure them. Now, these physical quantities again can be classified into 3 types. Scalars, vectors, and tensors. Now, tensors, we don't have enough portion. We will not deal with that. If you're doing civil engineering or mechanical engineering, so there you will study about them. So currently in our portion, we'll only stick to scalars and vectors. So what's a scalar? So scalars are these quantities which can be defined right? With a magnitude only. Meaning, if you just tell me the magnitude, I can define the quantity. I don't need anything else. It's like asking, like, I'm giving you 3 apples. Done. So how many apples I'm giving you? 3. So there is no other discussion there, right? I need not tell you I'm giving you an apple from north. I gave you 3 apples from east. I gave you 2 apples from south. It doesn't make any sense there. So giving a direction to these kind of quantities doesn't make sense. Imagine if money was a vector, right? And let's say your dad gives 100 rupees from left and mom gives 100 rupees from right. Money gets cancelled. Getting it? If money was a vector, that's how the money would have behaved. You wouldn't have any money if people give money from both the sides. But luckily, it doesn't work that way. Example, distance and mass, temperature, etc. Clear with this? Just the basics. Any doubts on this page? Standard stuff, standard definitions. Going ahead, next page. Turn in the page. Now, what is this vector? So these quantities which has magnitude, direction, and obey vector laws of addition and obey vector laws. So it has to satisfy something called vector laws also. So just because you have magnitude and direction, it doesn't work like that. I'll show an example where you have magnitude and direction, but it is not a vector. Example, force, velocity, these kind of quantities. So they have magnitude, they have direction, and they obey vector laws. But if you think about this, these kind of definitions, right, are called circular definitions. In order to define what is a vector, I have to use the statement it obeys vector laws. Did you see how it was? It's like this. Where do you stay? I stay beside my neighbor's house. Where is your neighbor's house? Beside my house. Can you see that argument, how it looks? So what is a vector which obeys vector laws? What is a vector law? We have to define what's a vector first of all. So unfortunately in science, it is most of the time it is like that. You explain one English word with more English words. Just try to imagine, how do you explain a blind person what is color red? So there are certain things you can't explain in words. Like, if a first standard kid comes to you and asks you, what is force? What do you tell him? Force is a quantity which does work and all. He'll be like, what are you talking? The best thing is kick him and show that this is called force. He will really understand. Then there'll be a fight with a different story. But so isn't that how you were explained in school? Force is pull or push. It was, you're able to visualize. So that is there. So something like this. So now here, for example, if you take current. So if you look at current has both magnitude and direction, but it is not a vector. Technically, it's called a tensor, but at least in 11th and 12th, we can treat it like a scalar. So we'll not get into that part, but this is not a vector. Getting it? So reason C. If you send current 5 amperes from this side, and if you send 5 amperes from this side, look at the same thing. If you apply 5 newtons of force from left hand side and 5 newtons of force from the right hand side, what will be the total force? F total will be 0 because they cancel out. So using the same logic, if I send 5 amperes from left side and 5 amperes from right side, how much current should come out? 0. But how much current does it come out? 10 ampere. Making sense? So this is not behaving like a vector. It is not obeying vector laws. Is that making sense? So current is not a vector. So current has both magnitude and direction, but does not obey vector laws. Getting it? So Therefore, current is not a vector. So be careful. Just because you have magnitude and direction doesn't mean magnitude is what? The number, right? 5 ampere, that's your magnitude. Right, Devanshu? You have 4 apples. What is the magnitude? 4. You walked 10 kilometers. What is the magnitude? 10. The number. Everyone clear with this? Just because you have magnitude and direction don't say it is a vector. You need to also obey something called vector laws. We will see what are those laws, but this is a simple way to understand. If you apply forces from two sides, they do subtract, but current doesn't behave like that. Now, in that sense, if we talk about it, what do you think is an area? Is area a vector or a scalar?
The vector.
Now, here again, the thing is, you need to understand something. Certain concepts, right, we define because it is more convenient. Meaning, before 1990, right, there is no chapter called vectors. My maths teacher who taught me maths, he doesn't know vectors. Because previously people were using vector concepts, but there was no formal chapter called vectors. So people made up this chapter saying, boss, the concepts we keep using, repeatedly. So we gave some applications for this. So if you look at the area, right, it is convenient to define area as a vector. Why? I'll tell you. For example, imagine you're in a room. Now let's say there's a door here. So imagine the area of the door is a scalar. And let's say we have a sensor here which measures the number of people who are crossing the door. Now let's say if 3 people go inside, what will the sensor measure? +3. If 2 people come outside, what will it measure? +2. Scalar, no? There's no direction. It'll just measure. If area is a scalar, this is what it'll measure. Let's say 5 people go inside, +5. 2 people come outside, +2. So end of the day, what did you get? You got the number of people crossing the door. Imagine there is some guy here who's standing here who's jumping inside outside, then what will happen? Then your counter will be +1, +1, +1, +1, +1, +1, +1, isn't it? You're not getting any proper useful data. But imagine instead of this, if this area is defined as a vector, and we have taken anything that comes outside is positive, anything that goes inside is negative. As simple as that. You define it as a vector. Now see what happens. 3 people have entered, -3. 5 people have come outside, +5. Let's say this student who is there is jumping inside, outside, inside, outside, inside, outside. What will happen? +1, -1, +1, -1, +1, -1. Did you see what happened? We eliminated that error. So end of the day, what do you get? We get the total number of people who left the room, isn't it? So defining area as a vector has more advantages than keeping it as a scalar. Is that making sense? So certain quantities you define because it is more convenient for us. So area is one quantity like that. So defining area as a vector is more convenient. So keep that in mind. We do certain things because it is more convenient. Later on, we will see there's something called a vector cross product and all that stuff. But technically speaking, in layman terms, this is what it is. So like I keep saying, you always need to have a definition. See, you need to have a technical definition. You also need to have a layman definition for you to understand. Keep this in mind. Whenever you're learning something, have a technical definition, great. But if you end of the day don't understand what you're talking about, then there's no point. Let me give an example what I mean by that. I'm pretty sure you must have heard the term momentum. What is momentum?
Product of mass and velocity.
Perfect. But do you really understood with happy, satisfied with the definition? Done. Momentum, mass and velocity. We understood everything.
No.
You're getting the problem here. Momentum, mass and velocity. You're not wrong. Great. So what? Did you even understand what the hell does it mean? So this is the thing, we know the definitions, we know the statements, we don't know what it means. Now, when I say what it means, you did not give me one more definition. You can even create an example or you can tell me something which will make you understand. For example, see, this is how I understand momentum. So momentum is meant to be great, but what does it mean exactly? Let me ask you one more thing. If something is traveling with a speed of 1 centimeter per second, everyone listening, if something is traveling with a speed of 1 centimeter per second, can you stop it? Right? We can stop it. Great. If something has a mass of 1 gram, can you stop it? So now think about it. If your local train is going with 1 centimeter per second, will you go and stand in front of it? If a bullet of 1 gram is going with a speed of 1 kilometer per second, you'll go and catch it? Did you see what happened? 10 seconds before, you're pretty confident you can stop a 1 centimeter per second and 1 gram. The moment I said train and bullet, your answers changed. So the thing is, you are not scared of the speed of the train. You got scared of the mass of the train. You are not scared of mass of the bullet. You got scared of the speed of the bullet. So what you're getting scared is not the mass, not the velocity, but the product. So what is momentum? We can say like this: higher the momentum of the body, more difficult to stop the body. Does that make sense? So when someone next time asks you, can you stop this? You need to ask, boss, what is the mass and what is the velocity? So when I gave only velocity 1 centimeter per second, I didn't give you full data. You saw the speed and you thought, yes, I can stop it. But when I said train, you got scared. Is that making sense? Now, see, this is not any technical definition, but you actually get the crux of, what is momentum. Momentum simply tells you how difficult it is to stop a body. Make sense? So keep this in mind. So, as you go ahead, you will be keep learning a lot of new things. So whenever you learn something, great. Understand the textbook or definition. Ratta maar lo, kuch problem nahi hai. But after that, also have your own definition. What the hell does it mean? This will help you a lot, because tomorrow when you go to a university or when you're doing a job or you're doing your own startup, people will come with a lot of hi-fi terms, but no one will explain to you in a layman terms. So it's quite useless if you don't understand what it means physically. So how do we define areas of vector? So we define areas of vector quantity. The direction is given like this. So if you have a plate or something, we choose a vector perpendicular to the plane. This is how we define area vector. So if you take any surfaces, area vector is perpendicular to the plane. We will talk about this later on. So for now, I have this much idea there. But if you take closed surfaces, what are closed surfaces? Your room, the cube, spheres, these are all closed figures. Closed figures, outward normals are taken as positive. Again, just a convention, you could have taken anything, but people prefer to take outside as positive. So if you have a cube, so a cube has 6 faces. That means there are 6 area vectors. So it'll be like this, like spikes coming out of the box. You're getting it? Each surface has 1 area vector. So a cube will have 6 area vectors. So if you take a sphere will have infinite area vectors. Every point, the area vector is coming out perpendicular to the surface. Like a porcupine. The spikes are coming out of the ball everywhere. So area is a vector quantity. So when we think about it, we say like, yeah, area looks like a scalar. Why the hell are you making it a vector? Like I said, it's more convenient. So we define area as a vector. It helps us a lot later on. We will see. So these are the 2 exceptions there. Be careful. Current has magnitude and direction, but it is not a vector. Area looks like it is a scalar, but it is actually a vector. Clear? So great. So we had a little introduction about what is a vector, what is scalar, what is this and that and this. So next thing. So how do you represent a vector? So listen to all this stuff. It looks a little basic, but quite important, because every chapter that you're going to see, these terms or terminologies will keep coming. So you should know.
Sir,
So when you give me something, yeah.
I didn't understand what did the red arrows exactly mean.
The direction, we'll see coming up there.
Okay,
When
sir.
you said what is a vector, what is a vector? Magnitude and direction, na? So direction क्या है? Arrow, right? That is telling you which direction it is.
Okay.
Yeah.
Then why have we taken the direction as perpendicular to the plane? Like plane, if you take the
See,
cube,
think of like this. If you have a door and if you come out of the door, how are you coming out of the door? Aren't you coming perpendicular out and perpendicularly in? Right? So think of like that. So let's say water is gushing out of a door or people are coming out of a door. So when people come out of the door, how do you come out? They come perpendicular to that door and enter perpendicularly into the door. So in and out. That's how we are taking the direction as. Like I said again, see, you defined it as a convenient vector, right? So the more convenient ways to define something is going in and out of the door. Clear?
Sir, what if we come at an angle and go in an angle?
So you are still going to enter the room like this only. You come like this, right? Imagine the door was like a thin slice. Don't worry about all that stuff. I know. Don't try to like you will say I'll go like this, I'll jump like this and go at an angle. We are just defining vector for this. We are not talking. See, then you're talking about something else. You're talking about your vector, isn't it? You are entering the door. That is your vector. We are talking about door ka vector. Clear with that?
Yes.
We'll see why it is perpendicular also. Again, there is also a reason for that. We'll see later on. One at a time. There are a lot of concepts. We can't throw all of them at the same time. So representation of a vector. So great. We said there is something called a vector, but how do you represent it? So there are a few ways to represent. First thing is a pictorial representation. So you want to represent the vector with pictures. So this is how we represent this. So this is the head. This is your tail. And this is your body. The length of the vector, the length of the body is proportional to the magnitude. Meaning the bigger the arrow you draw, it is understood the bigger the force. And the head represents the direction. So the head will tell you in which direction you're moving. Did you ever see the signs on a road? Or ever went to a mall and you see the signs there? They'll put like this. They'll put like this and they'll show arrows like this. Washroom is this way. The shop is this way. So what is that arrow trying to tell you? Which way you have to go to a certain place, right? So the head of the arrow will tell you about the direction. Everyone knows the symbol, right? Proportional. Maybe I'll just write it out. Length of the body is proportional to magnitude. That you will think it is some alpha or something. So now this is again your choice. For example, if someone comes and tells you this vector here is, let's say, 2 newtons. Kidding it? So if I want to draw 6 newtons, what should happen?
Should increase the
It
length
should be
of the
tripled.
Yeah, so if there's 6 newtons, I need to make 3 times the length, isn't it? This will be 3 times the length of 2 newtons. That's it. It is just a convention there. So you have to take a reference and based on that, you make the magnitude more. 3 times the length of 2 newtons. Did you ever see the map? In school, mein geography must have seen a map, right? They write something like this. 1 centimeter is 200 kilometers. Ever seen that?
Yes, sir.
It's called a scaling factor. So basically every 1 centimeter on the map is 200 kilometers in real life distance. But let's say you got a big sheet of paper, let's say you have a bigger paper, then they will write the same thing, 1 centimeter is 20 kilometers. Because you have a bigger paper, I can put it more detailed. You're getting it? So the scaling factor. Something similar here. So you can define any length as, 2 Newton or 1 Newton, but using that as a reference, you have to define other things. So this is how you represent a vector. You just put an arrow, you just show the length of the vector, and it is understood. It's a vector with this much magnitude and in this direction. Clear with this? So this is one way to represent, right? Pretty straightforward. We use this a lot. While I'm drawing pictures, we use this. So someone was asking here, like, sir, why are you drawing arrows, Anuj? This was the thing. So the arrow tells you in what direction is the vector pointing. Clear? Any doubts on this page? Ishman, all clear with this? Utsa? Clear with this? Adjust your cams a bit, everyone. Make sure your faces are completely visible on the screen. Advait, I can't see you. Utsa, I can't see you completely. Adjust our cameras a bit. Second thing, Arya, keep your cams on. Next thing is symbolic representation. So if you want to represent the vector with a symbol, then how do you represent that? So if you just say A, meaning it is understood it is a scalar. So someone is going to write like this, a body of mass 2 kg. So they will just say M is equal to 2 kgs. So if you just put a symbol, it's a scalar. Suppose if you put a symbol with an arrow on the top. So this is how it is pronounced, A bar. This is how we pronounce this quantity, A bar. So if you write like this, it is understood you're talking about a vector. This is called A cap. So this is pronounced as A ke upar, there's a small cap. So this A cap, this is called a unit vector. So basically this gives us a vector with magnitude 1. So this thing is important. So this A cap, right, this gives us the direction of a vector, meaning it tells us the direction. I'll tell you what it means. This thing gives the direction, that is, if you want to find the direction of a vector, someone tells you, see, for example, a person is walking 20 kilometers in the east. Which way did this person walk? East, right? So I will say 1 into east, na? Do I care how much did he walk? So the direction is simply east. So that is basically 1 times east. Did you see? That's a vector with magnitude 1. A person has walked 30 kilometers north. Which way did he walk? North, right? Do I care about 30 kilometers? The question is, which way did you walk? You walked north. Isn't that how you tell? So when you simply say north, aren't you simply saying it is 1 times north?
So
You're getting
how
the
did
meaning of
you
it?
get the magnitude as 1?
That is how the definition is, right, God? Which magnitude you're talking about?
North, when you take it 1 into north.
So if I say north, is 1 into north is north only, right?
Yes.
So that is 1 only, right?
Okay.
So if I say 2 kilometer north, what is the magnitude? 2, na? 3 kilometer magnitude is 3, right? But if I just say north, means what? It is 1 kilometer into north or 1 meter into north, whatever it
Okay.
is. It is 1 into north. Clear? So if you want to find direction, we will see how to calculate all this stuff, but we are defining it. If you want to find direction of a vector, calculate unit vector. So remember this, someone tells you, right? Find the direction of this so-and-so vector. Indirectly, what is telling you is find the unit vector. How to calculate that, we will see. So that is one. And then we define something called mod A bar. So this is how it is pronounced, mod A bar. So this thing gives you magnitude of a vector. So this thing tells you what is the magnitude of a vector. For example, a person is walking 15 kilometers west. How much did he walk? 15 kilometers, right? I don't care about the direction. You're getting it? So magnitude of a vector, I don't care about direction. Unit vector, I don't care about magnitude. So you have separated the magnitude and the direction. So this thing gives you magnitude of a vector. So this is how we define. So a unit vector is given by, if you take a vector and divide by itself magnitude, you'll get a unit vector. Isn't it? Think about this. A person walked 20 kilometers east. How much did he walk? 20 kilometers. Divide by 20 kilometers. Right? Or 20 number. 20 will cancel, you'll get 1 east. Is that making sense? So if you take a vector and divide by its own magnitude, it becomes a unit vector. So just remember this. Don't worry about this. We will do a lot of problems. You'll get the hang of it.
So,
Yeah.
isn't this
Aditya.
basically the definition of a vector? Matlab, if we just rearrange the terms, so a vector is equal to magnitude into direction.
Into direction. Perfect. That's what we're doing. So direction is vector by its magnitude. You can say like that. True. Any doubts on this page? All clear with these definitions? So this is how you represent them with the symbols. A bar, mod A bar, A cap. So these are the 4 symbols we have. Any doubts on this? Shrihari, clear this? Devanshi? Got this? Anuj, Ananya? Clear? Shaunak, Udit? Utsa? Great. Next thing. We are getting into the main part. So don't worry. I know all definitions. We will do some deadly problems also. I won't leave you before doing some deadly problems. So we have I cap. So we represent something called I cap. Remember, I cap meaning unit vector. So I cap is a unit vector along x-axis. J cap is a unit vector along y-axis. So you need to understand what we're defining everything, right? We are trying to represent stuff mathematically with symbols. So k cap is unit vector along x-axis, z-axis. So remember I cap, j cap, k cap. These symbols are important. You will literally see them everywhere. Let's see how to use them. So we define something called a position vector. So if the tail of the vector, remember for a vector, there is a tail and there is a head and there is a body. If the tail of the vector is fixed at the origin, the head represents the position.
Sir, but head was for direction, right?
Listen. You can ask me later on once I'm done explaining. So you have to give me some time to complete the explanation, right? Then if you're still confused, please ask. So look at this thing. So what is this thing saying? If you take a vector and fix the tail at this thing, this will be the head point P here. Let's say for convenience, this coordinate is x, y. Now you tell me, if I fix the tail at the origin, wherever the head is in the position of the head, the position of the particle or the position of the point?
Yes.
Anuj. If I rotate the head like this, now isn't this the head ka new position? The position of the head is the position of the point. You're getting it?
Yes,
Agreed.
yes.
It is giving the direction. The head represents the position. The head ka position jo hai, that is the position of the point. Now everyone listen to this thing. Huh? Now I'm telling you what is O to P bar. So we are writing a vector C here. O, P bar. Look at the meaning of the symbol. You're starting at O and you're going towards P. Can you see the arrow ka meaning now?
Yes.
That symbol ka meaning is the arrow is going from O to P. So it is saying we are going from O to P. Now, if I have to solve this verbally, what will I tell you? I will tell you like this, right? If you want to go from O to P, walk X units along X-axis and then walk Y units along Y-axis. Isn't that how we tell in Cartesian coordinate system? Is that making sense, everyone? Listen to this. This is an important thing. But tell me one thing, is it really that convenient every time I have to tell you walk X units along X-axis, walk Y units along Y-axis, and you'll reach the point P? So instead of that, what mathematically we try to do is this. So we will write simply OP bar is X into I cap plus Y into J cap. See what we did. So if you want to go from O to P, walk X units along I cap. What is I cap? Along X-axis now.
Exactly.
And then walk Y units along J cap. What is J cap? Along Y-axis. You're getting it? This is a mathematical representation of telling you if you want to go from O to P, walk X units along X-axis and Y units along Y-axis. Is that understood? Instead of me telling you every time that statement, this one definition xi cap plus yj cap is understood, boss, you're traveling X units along X-axis and you're traveling Y units along Y-axis and you reach the point. There. That is the meaning of I cap and J cap there. Instead of every time telling you X-axis, Y-axis, Z-axis, I will just write IJK and it is understood you're talking about XYZ. Clear with this? So we are converting sentences into symbols now. Just think about it. Walk 3 units along X-axis. Instead of saying that, I'll simply say 3 I cap. Isn't that the meaning the same thing? Walk 10 units along Y-axis. 10 J cap. You're getting it? Walk 3 units along Z-axis. 3 K cap. That's it. With one symbol and number, I'm telling you which way to walk. Is this understood, everyone? Any doubts on this page? So this is 2-dimensional. Now, if I go for 3D plane, same thing. Suppose if this point A is there, whose coordinates are A subscript X, A subscript Y, A subscript Z. So it is saying A ka X coordinate, A ka Y, and A ka Z. And if you're going from O to A, so this is how we write. Remember again, OA bar, we are going from O to A. So how should you go? Travel AX in X-axis, then walk AY along Y-axis, then walk AZ along Z-axis. Indirectly, am I not showing you just coordinates? X coordinate, Y coordinate, Z coordinate, I cap, X-axis, Y-axis, Z-axis. Is this understood, everyone? What is the length of this vector? So if I put a mod OA bar, this will give me the length of the vector. Length of the vector is nothing but distance between the 2 points. What is the distance formula? Root over ax square plus by square, ay square plus az square. Isn't that just a distance formula? Distance between origin and point A. Isn't that the length of the vector? Is that making sense, everyone? Then what is OA cap? OA cap is nothing but OA bar by mod OA bar. Just now we wrote this thing. So this is nothing but AX I cap plus AY J cap plus AZ K cap by root over AX square plus AY square plus AZ square. There we got OA bar ka magnitude, we got OA cap, we got everything about this thing. This is how we calculate the vectors of anything. You can put it down if you want. Put it down. I'll give you a minute if you want. Let's see a few examples so that I want you to get used to this IJ cap. It's easy stuff, but let's make sure you're not having any doubts on this. You can put it down. If someone is comfortable with this, then it is fine. No need to write it down. So if I give you 3 coordinates, and if I wanted to go from O to A, this is how you write. Let me do one thing. Wait, let me give you a better formula than this. You can write down that. But is this understood? I'll give you a better formula than this. For example, what if I don't want to go from origin? Going from origin is boring. Let's say I want to go from point B to point A. Bx, By, Bz, and let's say Ax, Ay, Az. So you want to travel from A to B. Can you tell me how will I write the vector? A, B, arrow will be like this. I want to go from A to B bar. So who is initial and who is final? A is initial, B is final. So final minus initial. So Bx minus Ax, that is the final x coordinate minus initial x coordinate. Which way are you going? I cap, x axis, plus By minus Ay, j cap along y axis, Bz minus Az, k cap. Is this making sense, everyone? So this is how you can go from one point to another point. Every time origin se jaane ka zarurat nahi hai. Right? And then, so if you split this open, you will realize this is nothing but Bx I cap, By j cap, and Bz k cap. So you can separate the two terms. Ay j cap, Az. If you look at this is nothing but a vector from origin to B bar. This is your OB bar. This is nothing but OA bar, isn't it? If you go from O to B and O to A, we get this. So if you want to go from A to B, you can directly write this thing as, you can find from O to B, you can find from O to A and subtract this. This is called a triangle law. We'll see later on. Don't worry about that. I just wanted to show you like you can get directly. So what is the magnitude of a vector AB bar? Distance formula between A and B, root over Bx minus Ax whole square. So indirectly, you know what I'm doing? I'm simply taking I ka coefficient ka square plus By minus Ay ka square. So I'm taking y component ka thing plus Bz minus Az ka square. This is how you find magnitude of a vector. So these are the main things to remember. This is how you get a vector AB bar. This is how you get a magnitude of a vector. If I give you 2 points, and AB cap is nothing but AB bar by mod AB bar. There. If you want to write down, you can put down the two things in the red box.
Sir,
This is a better one.
If a question asks to find the magnitude of a vector and they have specified the values of I cap, j cap, and k cap, so they've written.
Just square the coefficient. Iska square,
Yeah,
iska square, iska
okay.
square, and put a root. Done.
So that's just the square of the coefficients.
That is, yeah, that is actually the distance formula also, if you observe.
Yeah, okay.
Is this clear, everyone? Clear, everyone? Copied? Let's see if you have questions on this.
Sir, 1 second, I'm writing.
Let's see. So let's say we have 2 points here. A is 1 comma 2 comma minus 1. B is, let's say, 3 comma minus 1 2. Let's say C is 2 comma minus 2, 3. There I gave you the points. Find AB bar. Find mod BC bar. Find AC cap. Let's get them first. Find a vector with magnitude of BC bar in the direction of AC cap. So this is how they can ask you questions. There, let's get them. Let's start with the first thing. AB bar, mod BC bar, AC cap. And the second one, find a vector with magnitude of BC bar. So I want a vector whose magnitude is BC, but direction is AC. Give it a try. Don't worry about right and wrong answer. Whatever you think, you do it. It's okay to get a wrong answer. When I show you, you check and see what went wrong. And that is how you learn. Don't worry about perfection from day one. You are here to learn. Focus on learning. It's okay if you get wrong answers. If you get scared to do, wrong answers in a class, you will not learn anything. Every time you'll be just paralyzed by thinking I have to be perfect. Focus on efficiency. Try to learn from your mistakes. That's it. Keep it simple. Unlike school, in real life, out of 10 times, you fail 9 times. You learn from the 9 times. School is a messed up place. You lived in an illusion that everything is good and nice. You have come into the real life. Let's see. By now, AB bar must have been done. Look at the first one. What is AB bar? Ask yourself, you are going from A to B. So B is final, A is initial. So B final 3 minus 1. You have to subtract the x coordinates. 3 minus 1. Which way are you going? X axis, so I cap. Minus 1 minus 2. Which way are you going? Y axis. So minus 1 minus 2 j cap. 2 minus of minus 1. Which way are you going? Z axis. 2 minus of minus 1 k cap. So this guy will be 2i cap minus 3j cap plus 3k cap. Is that understood, everyone? Means if you want to go from A to B, walk 2 units along x-axis, then walk 3 units in minus y-axis, and then walk 3 units along z-axis. Then you'll go from A to B. It's like giving you an address. So looking at this vector, you can tell how to go from A to B. Is that making sense? So if I have to tell you this verbally, this is what I have to tell you. So from A, walk 2 meters along x-axis. Then from there, take a turn and go 3 meters reverse in the y-axis minus y. Then walk 3 meters along z-axis. Such a big one. I can just say this with one statement and it is understood. What is BC bar? I can find the BC bar vector also, or I can find the direction directly, magnitude from the distance formula. But let me find the vector. Again, I'll tell you one more time, listen. So BC bar, you're going from B to C. So C is final. 2 minus 3. I cap. Minus 2. Minus of minus 1. J cap. 3 minus 2. K cap. So later on, I'll be skipping this. I'll directly write it. So when you're learning 1 or 2 times, I'll show you. So you get the hang of it. Someone is confused, please ask, get them cleared. So the magnitude of BC will be, remember, you have to take the coefficient of squares. That will be root over. I ka coefficient is minus 1 square, and J ka coefficient is minus 3 square, and K ka coefficient is 1 square. That will be 1, 3, 1, root 11. Alright, did I mess
Sir,
up something?
minus 2 minus 1 to plus 1 हो
2
जाएगा
minus 3 minus 2 minus
j cap में सर
yeah, you're right. That would become how much? Minus j. I'm testing you guys whether you'll find the mistake or not. And you have passed the test. Isn't that what I'm supposed to say when I do a mistake? There. So that will be how much? Root 3? So be careful there. You can do goof ups like that also. There we got BC there. What about AC cap? Keep going. I'll give another minute for AC cap. I hope everyone got the hang of how to find a vector and its magnitude. Anyone is confused with this AB bar and BC bar, do ask. This would be the basic foundation. Like these things are standard. This is like your, what do you call, bread and butter. Or you can say dal and rice. Let's see the AC cap. So you want to find first of all AC bar. Directly can't go to AC cap. So AC bar, you're going from A to C. So C minus A, 2 minus 1. I cap minus 2 minus 2. J cap. 3 minus of minus 1. K cap. I cap minus 4J cap plus 4K cap. Right? Then find the magnitude of AC bar, which is root over 1 square. Minus 4 square is 4 square only. 4 square. That's 16, 16, 32 root 33.
Sure.
Yeah.
You've made an error in the J cap. It should be
Yeah. A to C, na?
okay, sorry, my bad, sorry.
Yeah.
Sorry.
No, okay, happens. I do a lot of mistakes, do correct me. Clear with this. AC is there, and then what is AC cap? AC cap is what? AC bar by magnitudes of its own vector. So divide this. So this guy is I cap minus 4J cap plus 4K cap and divided by root 33. You can leave it like this, no need to simplify further. That's how we get a unit vector AC cap. Clear with this. What about the B question? Find a vector with magnitude of BC in the direction of AC. Let me put it in a more simple terms. Listen to this thing. We have person A walking 20 kilometers north. We have person B walking 5 kilometers east. I want a vector which has the magnitude of A and the direction of B. What will you tell me?
20 kilometers east.
No, that is the logic, right? I want a magnitude of A bar, which is 20. I want direction of B bar, which is east, so 20 east, right? Is that understood?
Yes,
So
sir.
what am I asking in the second question? In the second question, you are asking me, find a vector with a magnitude BC. तो मुझे BC का magnitude चाहिए. And direction of AC, I want AC cap, isn't it? Isn't that what I'm asking? But we already know these two things. What is BC bar? We already calculated, which is root 3. And what is AC cap? Just now we calculated, which is I cap minus 4J cap, 4K cap by root 33. That will cancel out and you'll end up with I minus 4J plus 4K by root 11. Is that understood, everyone? So that is the meaning of that statement. Find a vector with magnitude BC. So this is the magnitude and this is the direction. So BC bar into AC cap. Is that clear, everyone? Any doubts on this? Everyone got how to find the vectors, right? Anyone not convinced with the magnitude, the direction, the unit vector, please ask me now. Don't hesitate, you can ask. In case you're feeling shy, you can type me in the chat box and always ask your doubts. If you're still
So,
feeling shy, please stay back after the class and get it cleared. बोलो ना.
so to find while we're finding AC cap and even here in the B problem, why do we keep the answer in the form of I cap, J cap, and K cap?
You find an AC cap, right?
Yes, sir.
AC cap is still a vector, no? It's a vector, it has direction.
So
Mod
can we
AC has no
substitute I
direction.
cap? Can we substitute I cap, J cap, and K cap for something?
No. Triola, am I pronouncing it right? How do I pronounce your name?
Triola.
Triola. Now see, I cap, J cap are not some symbols. Think of like this, people, everyone. I cap na. What is I plus J? Don't say 2. I cap, J cap are not symbols. For example, think like this. If I have 2 apples and if I have 2 oranges, what do I have? Do I have 4 apple oranges? No, right? It is 2 apples and 2 oranges only. You're getting it. This apple, orange, you don't mix them up. That is just a symbol there. So when I say 2i plus 2j, try to understand the meaning of the symbol. You're walking 2 units along I cap. I cap means x-axis. So it is trying to tell you verbally, walk 2 units along x-axis, walk 2 units along y-axis. Is that understood? So IJK are not some symbols.
Okay, sir. Thank you, sir.
Let's see the next one. This would be important. I hope everyone knows how to draw a cube. So first to draw a thing like this, I paid 1 rupee, to learn this. So listen, I'm teaching you for free. Then draw one more cube here. There, this is how you get a cube. So when I was in 6th standard, I still remember, first day of the class, one of my idiot friend was sitting beside me. He told me, Arun, do you know how to draw a cube? I said, I don't know. Then he said, you're gone. You're going to fail now. Teacher is going to send you back to 5th standard. If you're in 6th standard, you should know how to draw a cube. I was like scared. I said, yeah, how to do this thing? His name is Venkatesh. He's like, Theek, I will teach you, but what will you give me? I said, okay, I will give you 2 samosa and 1 sharbat. So that costed you 25 paisa is 1 samosa that time. And sharbat is 50 paisa. That was my pocket money for 3 days. 1 rupee I used to get every 3 days as pocket money. So this guy then taught me the cube. Draw a square, join them, you'll get a cube. I was like, yes, I know how to draw the cube. Break me, we went outside, he ate the samosa, he drank the sharbat, he was happy. So afternoon we came back class mein, so I was waiting. Teacher will ask me, I'll show her. I waited for the full day. Teacher didn't ask. Then I thought maybe teacher is busy. Tomorrow she will ask. I will tell her. Next day also waited. She didn't ask. And then I realized this idiot has fooled me. So yeah, happens. So this is X, Y, and Z. Look at this thing. I hope you're able to visualize the cube here. So remember, when you're saying X, Y, Z, again, listen, be careful. This is X. This is Y. What is Z? Z is coming out of the paper. Are you getting it? X is coming out of your, Z is coming out of your paper. So this is how we draw in 2D. So this point is your origin, 0, 0, 0. Let's call this O. This is a cube of side A. So let's say this is point A. This is point B. This is point C. C is the midpoint of this. This is point D. D is the center of that face, right? This is point E. These two are equal. This should do. So find AD bar, find BC cap, find AE cap. Let's get them these three. So we got a cube here and there are 6 points on this thing. O is the origin, A is this corner, B is this corner, D is the topmost point. So D is the, in your room you're sitting, right? D is the point where your fan is located. Isn't it? So D is the, on the ceiling midpoint. So D is the face center. That is a technical name for this. Cube has 6 faces. It is the center of the face. Face center of the top part. I'll just say face center, it is understood. E and C are midpoints of the particular sides. Let's get them. AD bar, BC cap, and AE cap. So your number 1 job is to first find the coordinates of these points. If you know the coordinates, you can find the vectors. So previous question, I gave you the coordinates, isn't it? And you found the vectors. Now I'm asking you to find the coordinates also. Let's get this.
But I'm not able to visualize this thing. Like,
That is a cube there. So this is x-axis, z-axis, and y-axis. This is the floor. This is the room you're sitting in. O is the corner. Just the room you're sitting in. Choose any one corner as an origin. Then you can see the wall, na? X, Y, Z. Floor pe X and Y is there. Z is what vertically is Z. No? Let's get the coordinates, everyone, first of all. God, you are able to visualize this thing, na? 3-dimensional sphere. Last class में. इतना कुछ समझ में आ रहा है. And cube, you are having difficulty. But did you understand the cube? Think of your room. That is a cube, right? So if you go and sit in the corner, this is the origin, na? अभी दिख रहा है room? So choose one thing as origin. So then A will be which one? For example, say I'll show you. Think of like this. Let's say you're sitting here in the center of the room. Where is point A? Look up, look to the right, and look at that corner. The wall in front of you, right ka top corner, that is point A, right? There. That is how you can visualize the room. D is the point where your fan is located. Top ceiling ka midpoint hai na D. Now you're able to visualize the room. Yep. AD. Right, Samyak. Oh, yeah, right. You got that thing. Anyone still having trouble with visualizing, please let me know. But first of all, how do we get the coordinates? Think, I'll give you another 30-40 seconds. Again, I'm telling you, don't worry about the answer. Forget about that. Try to figure out, try to learn, try to get as much as you can. I'll show you, then you can see what went wrong. How do we find the coordinates? Let me help you with this thing. Listen to this thing. You are starting from origin, okay? Now, when you're starting from origin and if you travel along x-axis, which coordinate will change? If you travel along x-axis, only x coordinate will change, right? And how much are you traveling? The side of the cube is A. So if you travel A units along the x-axis, you will reach this point. Its coordinate क्या हो जाएगा? A, 0, 0. Is that understood? If you're traveling along x-axis, only the x coordinate will change. If you travel along y-axis, only the y coordinate will change. If you travel along z-axis, only the z coordinate will change. Now from here, if I go straight up, you're traveling in which direction? I'm traveling in y. How much are you traveling? A units. So what should change? The y coordinate. Now remember, already you have this. In this, y is changing. So this guy will be A, 0. Is this understood, everyone? So from point B, from point A, if I go towards B now, this, you're traveling in which direction? I'm traveling in Z direction. Na? Remember, meaning the picture, right? I can't show you. It's a 2D, but this point B is actually coming out of the paper. Are you able to visualize that? A to B is actually coming out of the paper. Meaning it's like this. If you're looking into my screen, right? This is how it looks. So the point is going like this, and it is coming out of the paper. You're getting how it is? So you're traveling in which direction? You're traveling in Z direction. So what is this coordinate? A, A. Is that understood, everyone? Now from B, if I travel downward, which way am I traveling?
Minus y-axis.
I am traveling opposite to y, right? Minus y mein. How much are you traveling? A by 2, na? Half the distance. So x and z change nahi hoga, but y coordinate will subtract. What will be the coordinate of this guy? A, A minus A by 2, and A. Are you getting, everyone, what we're doing? So whenever you walk in a particular direction, only that coordinate will change. How to get E coordinate? If I go this way, what will be this coordinate? 0, 0, A. Then I will go up. This will be, I'm traveling in y direction, 0, comma, a by 2, comma, a. Any doubts on this? What is d coordinates? If I want to go to D, how should I go?
So you could go upwards towards y-axis. So
There are multiple
upwards,
ways, right? You
yeah.
can actually take multiple paths.
A by 2, comma, A, comma, A by 2.
Huh. So see, I will do one thing. I already know A, right? So from A, I will go straight like this. I will reach this point here, whose coordinates will be how much? Again, remember, I'm going in the negative x-axis. That will be A by 2, comma, A, comma, 0. Is that understood? Then from here, I will take a turn and I'll go like this. Now, which way am I going? I'm going A by 2 in the z-axis. So D ka coordinates kya hoga? So D ka coordinates will be A by 2, comma, A by 2. Is that understood, everyone? Please ask me if you didn't get any coordinates here. This is important. You should know cube ka every coordinate. Meaning from here, if I drop straight down, I'll reach the center, na? I didn't ask you, but if I come straight down, center bhi aayega. What will be the center ka coordinates then? A by 2, comma, A by 2, comma, A by 2. All are off. You're getting how to play around with the coordinates? So like that, you can travel from one point to another point. You just need to ask yourself, when I go from one point to another point, which way am I traveling? Am I traveling in X? Then X will increase. Traveling in Y will increase, and so on. Is this understood, everyone? Everyone got the coordinates? Now can you find them? Find AD, BC cap, and AE cap. Now it is easy. AD bar, BC cap, and AE cap. So the whole point of the question is to find the coordinates. Once you get the coordinates, it is easy. Get them. I'll give you a minute or two. So you are going from A to D. A ka coordinates are A comma 0. D is A by 2 comma A comma. I'll do one thing. I'll just write down D carefully here. It is scribbled a bit. A by 2, A by 2. So A minus, you're going from A to D. So D is final, A is initial. So A by 2 minus A by 2 I cap. Sir, I'm skipping steps now. Then A minus A, that is 0. So there's no need to write actually, but okay, 0 J cap. A by 2 minus A, so A by 2 K cap. This is AD bar. Clear, everyone? So you can write simply as A by 2 I cap plus A by 2 K cap. You can take out A by 2 common also. That is also fine. Then BC bar. First, I have to find BC bar. So you're going from B to C. Then I've done that also. So B ka coordinates are A comma A comma A. C ka coordinates are A comma A by 2 comma A. So BC bar, you're going from B to C. So C is final. A minus is 0. A by 2 minus A by 2 J cap. And that is also gone actually. That is also 0 K cap. So mod BC bar is A by 2 only magnitude. So BC cap will be BC bar by magnitude of BC. You can actually see and tell B to C, it is a direct path. So this guy will be minus J cap. You have to travel in minus Y axis to go from B to C. Is this understood, everyone?
Won't K cap be minus A by 2 for AD?
AD, you're going from A to D, na?
Yeah, so shouldn't be
A
minus
to
A by 2
D,
K
D
cap.
is final, A is initial, right? D
Yeah.
minus A, na?
Yes.
So A by 2 minus 0, right?
Okay.
Final minus initial. Yeah. Clear with this? What is AE? So A ka coordinates are 0 comma A by 2 comma A. A ka coordinates are A comma 0. So AE bar, you're going from A to E. So E is final, A is initial, 0 minus A, minus AI cap, A by 2 minus A by 2 J cap, A minus 0, A K cap. Mod AE bar root over A square plus A square by 4 plus A square. That's 2 plus 1 by 4, 4 to 8 root 9. So that will be 3A by 2. Got that? And then what is AE cap? AE cap will be, if I just take out A common there, I'll end up with I cap plus J cap by 2 plus K cap by 3A by 2. A gets cancelled out. You'll be left with minus 2 by 3. I cap, J cap by 2
minus
plus K cap.
the minus
No,
k.
minus
एक
k cap नहीं होना
minus
चाहिए
आएगा.
because you removed
Yeah,
minus
yeah.
out.
That would be a minus K cap. Clear? So the main thing in the question is to find the coordinates. Once you get the coordinates, it is just a matter of finding vectors. Any doubts on this? All clear with this? You guys want a small break or it's fine? Continue. We'll have a small break. Come back in 5 minutes. Go have some water, go outside, look into the something very far for 10-15 seconds. If you keep looking at the screen for so long, it does put a stress. Come back in 5 minutes. Let's see the next one. So let's say we have a circle. This is your x-axis, this is your y-axis. It's in a plane. This is your center. So here we have an ant. And the ant is walking along the circle with speed u. So this is time t is equal to 0. So initially ant is at on the x-axis. So ant walks along the circumference with speed u. Right? R is the radius of the circle. So now if the ant starts walking like this, can you tell me what will happen to the vector? Initially the vector, right? So we'll call ant is A. So this is the vector. After some time ant will go, so this is the vector, this is the vector, this is the vector. Can you see what is happening? As the ant is going, the arrow is also rotating. So after some time, the ant will come somewhere here. So let's call this point A. So this is vector OA bar. So this is the time t. So find the vector OA bar after time t. So answer will come in terms of R and T. Means for different values of time, if you put different times, I'll get different vectors, isn't it? Is the question understood, everyone? An ant is going along the circle with speed u. So OA, so OA is the position from the origin to the ant. So this vector is OA bar. So indirectly, I'm asking you find the coordinates of the ant after time t. If you let the ant walk for time t, it will go to some place. What are the coordinates? Is the question understood, everyone? Anyone didn't get the scenario? Please ask me. How do we approach this? Initially, the ant is at the origin, and this distance was r initially. So it was initially at r comma 0.
Sir, can you tell the angle to tell, I mean, with the
Nothing is
x-axis?
given, only this much information you have. Shreyansh, you have got something, right, Shreyansh? You have one answer, everyone. You got an answer? Type in the chat box to the co-host here. That is initial in array. You're telling me t0, you found the vector, na? Ri kya? After time t kya hoga? You tell me after time t, do you think this vector will still be like this only? I want I cap, J cap, na? Direction I want. I agree. See, no matter how long you wait, this distance will be always r only. But is the vector always r only? Right, Samyak, we got it. We have two answers, everyone. How do we approach? The headache is Like what Anuj was asking, that only. What is the angle? If I give this angle, my job is done, isn't it? So let's see how to get that angle. So remember, the speed of the ant is u, isn't it? The ant is going with speed u. In time t, how much will the ant cover? Distance is speed into time. So in time t, my ant will cover somewhere from here to here. It will travel all this distance here. Right? This is the distance traveled by the ant. Which is speed into time. But this is also equal to the arc length. Isn't that the arc length? So your ant has gone from here to here, and this is your angle theta, and this is r. And if you remember, that is the first definition we studied. What is the definition of arc length? Theta is arc length by radius.
R theta.
So from here we get the angle theta is the arc length s by radius, but s is nothing but ut by r. There. So that angle theta is changing with time. If I put t0, I get 0. If I put different times, I get different thetas. Is that understood, everyone? So we got different angles for different thetas. And then once you got this, so from here, if you drop a perpendicular, this distance is x and this distance is y. So this point A will have coordinates x, comma, y. So in that right angle triangle, you can clearly see cos theta will be adjacent side x by hypotenuse. So x is equal to r cos theta. Sin theta in the triangle is opposite side by hypotenuse. So y is equal to r sin theta. There I got x and y coordinates. What is OA bar? X coordinate into I cap, y coordinate into j cap. But what is x coordinate? R cos theta. But what is theta? R cos ut by r I cap plus r sin theta. Theta is ut by r. So the main thing is to find the angle. Once you got the angle, you'll get the coordinates. Once you get the coordinates, you get the vectors. You're getting how the relation went? So the main thing is to find the angle. Since the ant is going on the circle, I always know the distance traveled by the ant. That by radius will give you the angle theta. Everyone is clear with this? So theta was the main thing. Remaining everything, right? It looks a lot of variables, but it is nothing. Any doubts on this? Clear with this? Next one. Next one. Pratyasha, clear with this? Devanshi? Clear? Ashvi? Udit? Sudiksha? Clear with this? Advai? Any doubts on this? Ananya? Shlok? Bhavya? Got this? Next one. Let's see something better. We got a wheel. So we have a wheel here of radius r is rolling on the floor. So this point, the bottommost point is point A, and we consider this point on the ground as origin. Now, when this wheel is rolling here, the wheel is going forward and it is also rolling. How will the wheel go? The wheel will roll like this, right? If you're looking at my screen, the wheel will roll like this. So after some time, the wheel will come somewhere here. And in this process, this point A also will go somewhere here. You're getting, as the wheel is rolling, the point A won't remain at one place. The point is also moving. So A is a point on the circumference. I'll do one thing. I'll draw two different diagrams for you to understand. So this is the wheel. Radius of the wheel is R. This point is origin. This point is A, which is on the wheel. This is the scenario at t0. After some time, the wheel must have gone forward. Remember, origin is still here only. Origin will not change, but the point A is somewhere here now. Understood what happened? As the wheel goes forward, this is what will happen. And if you wait for some more time, the wheel will be somewhere here. The origin is still here only, 0, 0, but the point A must have somewhere here. You're getting how is this point A moving? If I have to give you the actual path, if you remember, I showed you this thing. Remember, this is called a cycloid. We had a discussion on this. Where are you, kinematics? There. This is how it will look, everyone. This is point A. Can you see how that A is moving? So this is the path of point A. Is this picture making sense, everyone? So if you put a point on your cycle ka tire, your cycle ka thing, when you're riding the cycle, this is how the point A goes. It is just jumping like this. This is called a cycloid. This is not a circle. Don't worry about that. It goes in some weird path like this. So the question is, so if this thing is going like this, so this will be the vector OA bar. And this will be the vector OA bar. So the vector OA bar is continuously changing. So the question is, if the wheel has rotated an angle theta, find OA bar. Find the vector O2 A bar when the wheel rotates by an angle theta.
Sir, is this advanced ka past year question or something?
So does it matter, right, Anuj? So what if I say if it is not, you'll stop doing it?
No,
Let's focus on the question. Nah? This is a waste of discussion, right? You're wasting your time and you're wasting everyone's time with this nonsense discussion. So let's focus on the problem. You have a doubt in the question, please ask me. Why does it matter if it's an advanced or previous thing? So see, think about it. It is an irrelevant question. Let's focus on the question. So A is a point on the circumference. Let's focus on learning, everyone. If it is tough, fine, let it be tough. You will learn. That is the whole point.
So is the speed of the wheel given?
It doesn't matter. Matlab, like I said, na, the wheel theta is given. Na?
Okay.
So initially, look at this vector here. Initially, this line, na, green line is like this. Now the green line became like this. After some time, the green line becomes like this. You're getting it? So the green line is rotating by theta. Meaning, if you look at the screen here, think of like this. See, if this is the wheel, if you're looking at my screen, right? And this is the rod, this is the rod there. So after some time, this thing is coming a blur. See. So if this is the wheel, now after some time, if it rotates, what will happen? This rod also will rotate, right? So now your cycle ka spoke jaisa, spokes. So if this was the wheel, and let's say we have spokes here. So in this, take this color and make it red. Now, if you rotate the wheel, kya hoga? The wheel will come forward, right? The spokes might look like this, but the point is the red one has come here, isn't it? So this thing has rotated theta. So ye process mein, how much did this point go? Is the question clear, everyone? Is the diagram clear? If the wheel rotates by theta, what are the coordinates of this point? Initially, point is at the origin. As the wheel goes forward, two things happen. The center is moving forward and the wheel is also rotating. Think for a minute, then I'll give you one hint, and then I'll give you 1 or 2 minutes. Then we will see. We'll go step by step. Don't worry. If it is tough, it is good. Means there's a lot of things to learn from it. So when you see something tough, always think of like this. There is an opportunity to learn something from it. You either get scared or you can think it's an opportunity. Let's see. Think for a minute. Forget about everything else. How do we even start? Kya ho raha hai? How? What is that? Why is that A going like that? What is it doing? Just keep asking questions to yourself. That's the most important thing. I'll ask you one question. Say, your scooty is there, your scooty or your car. When you're driving the car, how does the car know how many kilometers you have traveled? There's a speedometer, no? The distance keeps changing. Ovia, you want to say something? You can just unmute and say, no. How does your car know? My question is simple. Say, when you're driving the car, how does your car know how many kilometers you traveled?
Number of rotations into the circumference of the wheel.
Okay. You understood that, right? Or you're just saying it?
No, I understood.
Okay. Okay. So you're getting my question? Simple thing, no? When you're going on a scooty or your car, how the hell does the car know with what speed you're going? Kuch to hoga na? There should be some kind of mechanism to figure out the speed. The car just won't know on its own, right? So this is the thing, see. So imagine you take a wheel. So let's say I paint this with a red color. So I'm painting this with 1/4 with red. Then let's say I'm painting this color with green. Then let's say I'm painting this with some sky blue color. And let's say if I paint this with some black color. So I'm just painting with 4 different colors. Now tell me, if I roll this wheel on the floor, what is the first color you will see? The red part.
Red.
So this entire thing will be painted with red and this will be B. Then you will see the whole thing is painted with green and you will see C. Then you see this whole thing is with the sky blue thing, you will see some D. Then you'll see this whole black thing and again you'll come back to A. Did you notice something here? That means if I make one full revolution, the distance between the center to center, this distance will be how much? 2 pi r. Is this understood, everyone? So whenever you roll a wheel on a floor, when this thing completes one revolution, the center of the wheel will travel a distance of 2 pi r. So this is a concept. So in one revolution, the center of the wheel travels 2 pi r. Right? Ovia, your J is right, I cap is wrong. Getting it? Is this understood? So next time, right, when you're going on your scooty or something, na, scooty ka dekho, if you have an Activa, right, the front wheel, there are 2 wires going. One is a brake wire and one is a sensor. If you remove that wire, it will stop counting the distance. So what happens is there's a sensor there which counts the number of revolutions, right? And if you do number of revolutions into 2 pi r, that will give you the distance traveled per second. You're getting it? So that is how your vehicle knows how much distance you're traveling or what speed you're going. It counts the number of revolutions and multiplies by 2 pi r. Is this understood, everyone? Now, getting back to the question. So if you do one full revolution, you will travel how much distance? 2 pi r. What if you travel theta distance? For 2 pi angle, you will travel a distance of 2 pi r. For theta distance, you will travel how much? So if I travel x, then you can use unitary method. X will be r theta. Make sense? Theta into 2 pi r by 2 pi. It's just, you can see it's a linear function there. That means when I took this wheel here, and when the wheel rotated by theta, look at this. So this was point A. So this line became like this. That means from this bottom point, the center to center, this distance is r theta. Is this understood, everyone? If you make one full revolution, you will travel 2 pi r. If you make theta revolution, you will travel r theta.
So, sir,
Agreed with
basically
this?
the arc length, right?
The arc length basically. यहीं पे जो length था वही यहीं पे आएगा नीचे floor में. The diagram is not up to scale, but everyone got this. Then we are done, right? It is just geometry now. So this is origin 0, 0. This coordinate will be r theta, 0. So this is point A. This is radius r. This length will be adjacent side r cos theta. This length will be the opposite side r sin theta. So if I just redraw the diagram here, look at how it looks. So this was the origin 0, 0. This was the point r theta, 0. So if I go up here, you can clearly see this distance will be the total height r minus r cos theta. So if you go up, this is r minus r cos theta. So this coordinate is r theta, r minus r cos theta. And you want to go this way, that is point A. How much are you traveling inside? R sin theta. So r theta minus r sin theta, you're going back, r minus r cos theta. That is the coordinates of point A. Are you getting what we did? Once we got that concept that the floor mate has traveled r theta, isn't it just a matter of geometry there? Then the vector OA bar will be r theta minus r sin theta I cap plus r minus r cos theta j cap. Is this understood, everyone? Did everyone get how did I get the coordinates? So I went straight like this, then I went up, then I took a turn left side. Then it is just x and y coordinates. Any doubts on this step? Yeah, you could solve it. Now, does it look that tough? It looks scary, that's it. It is just scaring you. But the main idea is this. Any doubts on this? Anyone didn't get any part of it, please ask me. You're going to again encounter this problem in kinematics. There I will ask you, this point A is going like this, na, arc. I will ask you to find the length of this curve. We're going to find the length of the curve later on. We need calculus and everything. Right now we can't do, but it's going to come back again. Remember this. This is not an advanced question. Who told this in advance? You guys started assuming it because I showed 2-3 diagrams. Not you, I'm talking to Ali. Clear with this thing? Any doubts on this? Let's see one more. Shlok, clear with this? Tanishka? Clear, na? Vanshika? Clear? Ishman? Advai? Aditi? Devanshi? Clear? Ananya? Got this? Next one. We have a vector OA bar. Now, sometimes we are lazy, so we will write it as A bar. So be careful, it is the same thing. Sometimes in some books you will say OA bar, sometimes you will say A bar. It is not different. So this is 2i plus 3j, let's say 3i plus 4j minus 5k cap. Then what happened? Someone took this vector and they rotated it. Vector OA bar is rotated by an angle theta. And it becomes OB bar. So there is no information what angle you rotated, how you rotated, and everything. It becomes OB bar, right? Where OB bar, again, if you are lazy, we'll write it as B bar. This became 2i plus xj minus k cap. Find x. So you have a vector which is 3i, 4j minus 5k. You rotated this and it became 2i xj minus k. Then what is x?
So does this involve 3D coordinates?
Doesn't matter now. You can't ask this in the exam, right? Try whatever you think. Where am I running away? I'm going to teach you in a minute. But this is all the information you have.
Sir, but in which axis are you rotating it? Like,
This is the whole question. Unfortunately, in the exam hall, you can't ask the coordinator, right? That person has no clue. This is all the information you need. You don't need anything more than this. If there is something more needed, I would have given you. So don't worry about that.
Is my answer correct, sir?
No, it's not right. Right, Samyak. But Samyak, there are two answers.
Sir, it will be plus minus.
Yeah. Think. Just a small trick. नहीं होता. Right, Pratyasha. So listen to this thing. So we got a vector OA bar. I don't know how it is rotated, but it is rotated to OB bar. Something didn't change. Vector changed, but something didn't change.
Magnitude.
Magnitude, right? No matter how much you rotate a vector, will the length of this vector change? Are you getting it? So that's your statement there. Magnitude of a vector does not change with rotation. You can rotate it however you want. That length of the vector, the length of the body does not change. That's it. So once you got this, I don't care about the theta. Indirectly, you're telling me magnitude of OA bar must be equal to magnitude of OB bar. Is that understood, everyone? So what is A bar ka vector? A is 3, 4, 5. So root over 3 square, 4 square, 5 square will be root over OB bar is 2 square, x square, 1 square. Put square root on both sides. This will become 50. This will become 5 plus x square. We get x is plus or minus root 45. That will be plus or minus 3 root 5. There are two answers, everyone. That's it. That is the main idea there. If you rotate a vector, the magnitude is not going to change. You don't need theta, you don't need axis, you don't need anything about like that. Is this clear, everyone? Any doubts on this? Last class I have given you some sheets. You don't tried those things? Any doubts on those?
Sir, I
You can
have
see
a
them. We'll see. But I think most of the things were easy only, right? Straightforward questions.
not in the
Maybe one
sheets
or
that
two.
you
Okay. We'll see. If you have any other doubts other than the sheets, we will see end of the class. But everyone clear with this question? Great. Let's see one more thing. The next thing is types of vectors. This is an easy chapter. You really can't ask really high level questions on this thing. Like I said, you're right. This will be a part of some other chapter. It's like think of like this. It's like curry patta. You can't make a curry with pure curry patta, right? It is like you add it in some other dish. Vectors is like this. So you want to see vectors? It will be. I was just teaching your seniors today. So for them, the vectors, right? If you see, vectors will look like this. 2k lambda 2 by x I cap, j cap, op cap. So
Sir, what
this is how the
was
vector
OP
looks.
cap?
I cap and j cap. So you will see vectors like this. So this will be part of some other big chapter. You'll have integration, that, this, everything mixed up. So kind of like that. See, this is how the vector forms. So we use integration and vectors, we combine them. You get all different kind of stuff. So you keep getting I cap, j cap, c. This will keep popping up everywhere. This will be part of some other chapter. OP cap is what? Unit vector, right? O to p ka direction. So what are parallel vectors? Straightforward definition. Don't worry, that is next year we'll reach that level. So vectors with same direction, simple thing. You say two vectors are parallel if they're same direction. I don't care about the magnitude. Suppose if I say like this, there are two people, one guy is going 10 kilometer west and another guy is going 2 kilometer west. Are they going in the same direction? That's it. They're going in the same direction. Means parallel. So if you have a vector a bar like this, and if someone is going parallel to this like b bar, so you can write a bar is equal to k into b bar. This is how you represent. If k is a positive constant, then we say the vectors are parallel. If k is negative, means a bar and b bar are opposite actually. So a bar will look like this and b bar will look like this. These are called anti-parallel vectors. Clear with this? So whenever you have two vectors like this, a bar and b bar, so if you have a bar is ax I cap, ay j cap, plus az k cap, and if you have b bar is bx I cap plus by j cap. I'll just write on the next page. Ax I cap, ay j cap, az k cap. Remember again, ax, ay, az are simply coordinates, x, y, z coordinates. Instead of writing x, y, z, I'm saying a ka x coordinate, a ka y coordinate, a ka z coordinate. That's the meaning of it. Bx I cap, by j cap, and bz k cap. So if the vectors a bar is parallel to b bar, this is how we represent if vectors are parallel. We just put two lines. Then just now we saw a is equal to bx. So coefficient of I cap, so ax by bx must be equal to ay by by is equal to az by bz. This will be equal to some constant. So they'll satisfy this condition. So every component should be parallel to each other. Think of like this. If a person goes like this and goes like this, if you say you're going parallel, doesn't it mean you're going like this and going like this? So they should be in the same proportion. They should look same thing, only it got little bit extended. Quite a useful result. So if two vectors are parallel, this is the condition they should satisfy. Clear with this, everyone? And we can also write, if A bar is parallel to B bar, you're saying the directions are same. That means A cap is also equal to B cap. Do you agree with that? If two vectors are parallel, then their unit vectors must be equal because they're in the same direction. If I go 10 kilometer west and you go 5 kilometer west, we both went west. So our directions are same. Is this clear, everyone? Have a look at this thing. Any doubts on this page? Clear with this? Let's see a question. So we have vector A bar, which is 2i minus 3j and 4k. Let's say zk. And let's say vector B bar, which is 4i plus yj plus 3k. Find the value of y and z if A bar is parallel to B bar. Let's get this. So we have two vectors, 2y minus 3j plus zk. So z ka number, I don't know the value of z, it's a variable. This is y, I don't know the number of this thing. But it is given A and B bar are parallel. Then what is x, what is y, and what is z? Get this simple question. Right, Samyak. Right, Obya. Just now I taught you, if two vectors are parallel, their coefficients ka ratio must be same. Finish it off. 30 seconds. So if two vectors are parallel, ax by bx, ay by by must be equal to az by bz. Straightforward. So this is 2 by 4 must be equal to minus 3 by y is equal to z by 3. If I cross multiply these two, I will get y is equal to minus 4, 3, 12, minus 6. If I cross multiply these two, I will get z is equal to 3 by 2. Easy. Is it understood, everyone? So solve these two, then solve this one and this one. So basically it is half, the ratios are equal to half. Any doubts on this? Simple one. So if you take a vector and if you just shift it parallel to itself, it does not change. A vector does not change by shifting parallel to itself or itself, along itself. What do you mean by that? See, for example, if I have vector A bar, if I push it forward with the same magnitude, did the direction change? If I go backward, did the direction change? If I keep it parallel, did the direction change? So if you see, all these are A bars only. You can shift the vector up, down, right, left, anywhere, as long as you're pointing in the same direction, you're still looking in the same direction. So shifting a vector front and back, left and right, it's, if you just shift it parallel to itself, nothing happens. It changes when you rotate it though. It changes when we rotate. Keeping the magnitude constant. We have done this question. So if this was A bar, and if you're going to rotate it, it will become B bar, but the magnitude remains constant. Direction changes. Clear to everyone? There. So that's a bit about vectors. So make sure to go through the whole thing. We did some basics and definitions today. Next class, we'll do something very important. We call it resolving a vector. That is also easy, but primarily we are going to do a lot of applications on that. That will be the main essence. Like, we're going to use that a lot in mechanics and everywhere. So next class, we'll do more better problems. Okay, so that is one. So there are few things